Lesson 1, Developing Systems of Linear Equations. So system of linear equations really just means more than one linear equation, so more than one line. So what we're going to do is we're going to go through some examples of word problems that could be turned. Okay, example 1. Tickets are sold for a school play. Felix buys 3 adult tickets and 2 student tickets. He pays $31. Ellen buys 1 adult ticket and 1 student ticket. She pays $12. So what I want you to do when you develop these systems is I want you to put a square around the numbers that have to do with the first equation and a circle around the numbers that have to do with the second equation. So first of all, Felix has 3 adult tickets and 2 student tickets, and he pays $31. So there's our first equation. And our second equation is Ellen, who buys 1 ticket, that's an adult, 1's a student, and she pays $12. Next, what I want you to do is I want you to set your variables. So I want you to write a let statement. So let A equal adults and S equals student. And I want you to choose variables that make sense to the equation. So it doesn't have to be X and Y. A for adult, S for student. That makes sense. Use letters that make sense. Now you're going to write your 2 equations. So for the red numbers, we have 3 adults and 2 students. And together, you pay $31. So that is the first linear equation. The second is you have 1 adult and 1 student, and that equals $12. So there's your 2 equations. Together, they are a system of linear equations because you have more than one equation. Part B, 8 passenger vans and 6 passenger vans carry 110 people. Let's put a square around that. 8 passengers and 6 is 110 people. There are 115 vans in all. So now we're going to do our let statements. So let's let E equal 8 passenger vans. And let's let S equal the 6 passenger vans. Now if we add together E plus S, so the number of 8 passenger vans and the number of 6 passenger vans, we have 15 vans. Now to write our second equation, we're going to have E and S again, but now we're talking about the number of wheels, or passengers. So 8 passenger vans have 8 people, so we need to do 8 times E. And 6 passenger vans have 6 people, so 6 times S. And altogether there's 110 people. So here's our system of linear equations. A gardener bought carrot seeds for $2 a package and squash seeds for $5 a package. So $2 a package, $5 a package, and he spent $38. And altogether he bought 13 packs. So let's do our let statement. So let's let C equal carrot and S equals squash. So if he bought 13 packets together, if you add C plus S, so the carrots plus the squash, you have 13 packages. Now we're going to deal with the money. So it's $2 for carrots and $5 for squash. And altogether it's $38. So there is your system of linear equations. The school sold 175 smoothies to raise money for a charity. Oops, that should have been red. There's banana smoothies, and they cost $3, and peach smoothies, and they cost $5. Together, the school raised $625. So let's let B equal banana, and P equal peach. So if we add up the bananas plus the peaches, we sold 175 smoothies. And bananas cost $3, so 3 times B. And peaches cost 5, so 5 times P. And I wrote another B. There we go. And altogether they made $625. So there's your system of linear equations. The total number of wheels on bicycles and tricycles in a store is 45. There are 10 more bicycles than tricycles. So let's let B equal the bikes and T equal the tricycles. So we're adding bikes and the tricycles, and we're talking about the number of wheels. So bicycles have 2 wheels and tricycles have 3 wheels. And altogether in the store, there are 45 wheels. Now the second equation. There are 10 more bicycles than tricycles. So our bicycles is equal to your number of tricycles plus 10 more. So this is your system of linear equations. Dalton has $5 bills and $10 bills in his wallet. He has 12 bills with a total of $75. So we're going to let F equal $5 bills and T equal $10. So if we have our F's plus our T's, you have 12 bills. $5 bills are worth 5, so 5 times F, and 10 are worth 10, so 10 times T, and you have $75 altogether. So this is our system. An art gallery has a collection of 85 people masks and animal masks. 60% and 40% are yellow. There are 38 yellow masks altogether. So now we have to make our system. So let's let P equal people and A equal animal masks. So if we add up the people and the animal masks, there's 85 masks. 0.6 is the same as 60%. So whenever you have a decimal or a percent, change it to a decimal. So 40% would be 0.4. So 0.6% of people masks plus 0.4% of animal masks are equal to 38 yellow masks altogether. So here is our system of linear equations. A store display had packages of 8 batteries and of 4 batteries. The total number of batteries was 320. And there are 1.5 times as many packages of 4 batteries as 8 batteries. So let's let E equal 8 batteries and F equal 4 batteries. There we go. So our system, first we have 8 packages and 4 packages, and there's 320 batteries. So the 8 packages have 8 and the 4 packages have 4. So there's our first system. And there are 1.5 times as many packages of 4 batteries as 8 batteries. So we know that the 4 batteries is equal to 1.5 So there's 1.5 times as many 4 batteries as the 8 batteries. So there's our system. Part B says, check to see if the following solution satisfies the equation. So 30 packages of 8 batteries and 20 packages of 4 batteries. So the way that we check to see if a solution satisfies the equations is to substitute E and F into both equations. So 8E plus 4F is equal to 320. And 8 times 30 plus 4 times 20 is equal to 320. This is 240 plus 80 equals 320, and if you add them together, 320 does equal 320. So that means that this satisfies our first equation. Now we want to check the second equation. So 1.5 times 20 is equal to 30. Type it into your calculator and you get 30 equals 30. So this satisfies our second equation too. So E equals 30 and F equals 20 is a solution to the system of equations.